All right. Kejap eh. Okay, Assalamualaikum semua. So for today's lecture, we are going to um, learn about logistic regression with ordinal outcome data. Okay, logistic regression with ordinal outcome data. So again, the objective of the module or the lessons uh, are these. Number one, to understand the concept of logistic regression model for ordinal outcome data. Okay, number two, to be able to perform estimation, meaning that we will be able to get the beta value, the standard error. Usually the beta value and the standard error. Okay, maybe the likelihood. Okay, the log likelihood. And for variable and multivariable logistic regression. And then to be able to perform inferences. Inferences meaning that how can we generalize results to population of interest, maybe lah. Huh? So usually we do this by getting the 95% confidence interval. At the same time, we check for the p value, and then to be able to make prediction for univariable and multivariable uh, logistic regression for ordinal outcome data, and to check for model adequacy. This is a little bit challenging lah, okay, to check the model adequacy in model diagnostics for ordinal outcome data. So I'm not sure whether we are going to go in detail or not. So the motivation for this lecture, okay, we know that some data come with ordinal outcomes, meaning that uh, the outcome variable has more than two categories. Has more than two categories. So three or more categories. And we know that we could analyze this with multinomial logistic regression, like we learned before. However, multinomial logistic regression applies to outcome variable that does not have uh, what we call ranking or ordinality, or ranking or ordinality is not important for the analyst. When the ranking is important or the outcome categories are important in terms of the rank or ordinality, then there is a better method to do that, which we are going to learn now lah. Okay, but you still can um, use uh, uh, nomial logistic regression. We'll come to that later. Yeah, like I said here, you still can use um, multinomial logistic regression to analyze data with ordinal outcome. However, one limitations in doing that is that the analysis will not address the ordinality of the outcome. So that one of the major weakness if you use multinomial logistic regression, when the outcome is categories with ordinality. So a better analysis would be maybe would be ordinal logistic regression. However, it is not the not the only a model or the only analysis available to analyze data with ordinal outcome. Okay, so this is specific. Ordinal logistic regression is quite specific. So but there are more than this model, a few more, when we want to analyze data with ordinal outcome. Okay, so I think I should correct this lah. Okay, a better analysis is analysis that can, or analysis that treat ordinality as the outcome. I think that would be the better sentence here. Okay, so we don't restrict ourselves to ordinal logistic regressions, because there are other what we call analytical method, you know, uh, in addition to ordinal logistic regression to analyze this. Like I said just now, ordinal logistic regression is one specific analysis. Okay, and basically that is the analysis that most people will use when they want to analyze data with ordinal outcome. Okay, we understand that. Okay, that's why I mentioned before. But that's not the only model. Okay, because other models include adjacent category logit model, continuation ratio logit model, and the proportional odds model, which is also known as the cumulative logit model. So three models: adjacent category, continuation ratio, and proportional odds model. So this model are explained in detail in Hosmer-Lomeshaw applied logistic regression. So if you have time, go back and read. In adjacent category logit model, the log odd does not depend on the response, and the log odd is linear in the coefficients. So when you write the model, you write as the log probability of yi equal j over probability of yi equal j plus 1. So you remember, let's say j is the outcome number 1. So probability yi equal 1 divided by probability of yi equal 1 plus 1, which is 2. So it means they are comparing between 1 versus 2, right? So which equals alpha j, or the intercept for j, which is, if j is 1, so this is 1, intercept for logit 1 plus b x1. So if you have uh, three categories, right? 1, 2, 3. So this will become 1, 1 plus 1, 1 versus, so 1 divided by 2, 1. If it is 2, 2 plus 1, so 2 and 3, this one intercept for logit 2. But again, that depends on the on the software. Depend on the software. Okay, this is the one that you can find from Hosmer-Lomeshaw book. Okay. In binary logistic regression, it's quite simple because you have 1 versus 0, right? 1 versus 0. Okay. Probability of y equal 1 versus probability y equal 0, or you are dividing the odds between the two outcomes. Okay. So this is in adjacent category. It means that you compare category J with the neighboring category, which is j plus 1. Okay, if category 1 you compare with category 2, if category 2 you compare with category 3, so on and so forth. So it is like multiple binary logistic regression kan, right? And we don't write here beta or beta 0 because this is the beta for that logit, okay, for that group, right? Okay. In continuation ratio logit model, okay, we compare each response to all lower responses. For example, y equal k versus y uh, less than k. So for example, if we have 1, 2, 3, right? So if we have 1, 2, 3, let's see if I can write on this. Nope, I cannot write on this. Okay, tak apa. So it means that we are comparing between, let's say we got group 1 to outcome 1 to 3. So if k is 3, we are going to compare k versus group 1 and 2 combined. Okay, if k is group 2, then we are comparing 2 versus 1. Okay, let's say if we got 4 categories, the outcome variable has 4 categories. Okay, uh, 1, 2, 3, 4. Sorry, 4, 3, 2, 1. So we are going to compare 4 versus 1 plus 2 plus 3. Okay, if we are comparing group 3, we are going to compare it between 3 versus 1 plus 2. Okay, so we are going to compare each response to all lower responses. Again, this depends on the software or the statistician that designed the software, because because all these formula are are quite flexible. You can turn this way, you can turn that way, so it depends on the statistician. If you read Hosmer-Lemeshow, then Hosmer-Lemeshow um, um, use this concept. It means that in continuation ratio logit model, you are going to compare uh, k versus other groups combined lower than k. When we go to practical later, then I think you can see this more clearly. So because of that, the continuation ratio logits have different constant terms and different slopes for each logit. And the last one is the proportional odds model or cumulative link logit model. So this is the most commonly used model for data with ordinal outcome. Okay, so proportional odds model or cumulative link logit model or ordinal logistic regression, different names, but the same concept. So the proportional odds model compare the probability of an equal or smaller response y equal or smaller than k to the probability of a larger response y bigger than k. Again, this depends on the statistician, this depends on the books, this depends on the software, because you can flip this formula around and it means the same thing, it's just that different approach. In Hosmer and Lemeshow, in the book, it is written as y equal or less than k against y bigger than k. So if you have um, category, if you have like 4 categories, right? 1, 2, 3, 4. So you are going to compare 1 versus 2 plus 3 plus 4, and then 1 plus 2 versus 3 plus 4, 1 plus 2 plus 3 versus 4. Okay, because you are comparing the probability of an equal or smaller response to the larger response. And I think that is the same approach in software like Stata. However, if you use software like, I think, SAS have a different approach. It's compare the larger uh, response um, to the equal or larger response to the smaller to the small response. Okay, so for example, instead of 1 versus 2 plus 3 plus 4, it will compare um, 2 versus 1, and then 2 plus 3 versus 1, 2 plus 3 plus 4 versus 1, something like that. Okay, um, I, I have to check it back. Okay, but roughly it will be the same. Okay, it's just that different approach, but the same concept. That's why it is called as proportional odds model. So if you have j categories of outcome, okay, j equal 1, 2, and c minus 1. So you are comparing the probability of y equal or less than j, which is this one k, against probability of y bigger than j. Maybe I should have used j here, not sorry, k here, not j. Yeah? So um, yeah, that's how that's how proportional odds model work. Okay. So now what you have is the logit of probability of y equal or less than j. This one comparing between two groups, 1, 2, 2, 3, 3, 4. This one will um, compare also, compare using binary logistic regression too. And again, and this one, the proportional odds model, measure the probability of equal or smaller response to a probability of a larger response. Okay, so 3 different approaches at least to analyze data with ordinal outcome. There are more models out there, okay, but most of the time in epidemiology, these are the 3 used model for ordinal outcome data. Um, so I won't go into details for adjacent category and continuation ratio, because we can do that in the practicals. And secondly, most people will avoid using these two model. Okay, instead they will go straight to proportional odds model, cumulative link logic. But again, if you use proportional odds model, even though it is maybe easier to perform, however, you have to fulfill one additional assumptions. There is assumptions of proportionality. Okay, for example, okay, now let's imagine we have run a proportional odds model, or the cumulative probabilities logit or cumulative link logit model. They are all the same. So let's say we have an outcome d. Okay, d, variable d, outcome, categories. How many categories? 3, coded as 0, 1, and 2. And then we have a covariate age. Okay, a covariate age, a numerical variable. Okay, and we run this proportional odds model or cumulative link logit model or ordinal logistic regressions, they are all the same. Okay, proportional odds model slash cumulative link logits model slash ordinal logistic regression. And assuming we have an intercept of alpha j, and we have the beta value of 0.20 and the standard error of h of 0.05. So the odds ratio is just by exponentiations of the beta value. So you exponentiate 0.20, then you get 1.22, which means that for a year increase in the age, then the odds to be in the higher versus lower category of outcomes becomes 1.22 higher. Okay, so it means that if you if the population has uh, increased in the age by 1 year, then the odds to be in the higher groups versus the lower groups becomes 22% higher, right? So the older your age, then the higher the risks to be on the bigger category or the higher category. Okay. Uh, Maybe we have to check here, okay? Because this one, as I've told you, I've used two books for ordinal outcome data. One for Hosmer Lemisho and the other one for from Claimbound. Um, and they use different definitions, uh, even for professional odds model. So I could see that this is comparing higher versus lower, but when I mention here is uh, smaller versus higher, right? So they are all the same. The concept is that you are comparing the higher or the bigger or the smaller groups against uh, the bigger or the lower groups. Okay, it's just that either you use this formula or that formula, right? So I check the book again and also check the software that you are using. Okay, right. For confidence intervals, same principles. You get the beta value and you get um, the constant value for 95% confidence is the interval, which is 1.96, and you times with the standard error of the beta will be the same, right? So um, but again, you have to exponentiate first before you convert. Sorry, you have to plus the beta value plus 1.96 times standard error and beta hat minus 1.96 times standard error. Then only you can exponentiate to get the odds ratio. So the 95% confidence reflects in a larger study 95% of the time the true values of the in the population will lie between the 95% confidence intervals. For a categorical covariate, okay, again, if we have um, outcome coded as 0, 1, and 2, so if we have gender, male coded as 1 and female coded as 0, So you are comparing group D larger or equal than G against group D smaller than G. Okay, so they are different, not contradicting, but actually different authors use different definitions of the proportional odds model. Okay, so you can exponentiate the alpha G plus beta 1 x1 to get the odds, right? So if let's say we got the beta value for sex equal minus 0.285, we exponentiate this and we get 0.752, then we know that men have 24.8%. Okay, I missed percent there. Okay, men have 24.8% less chance to be in the bigger category of the outcome. Okay, because I think this example comes from Hosmer-Lemaitre, and Hosmer-Lemaitre use higher versus lower, whereas um, higher versus lower, higher versus lower, and highest versus and while Clembaum use smaller versus bigger. Okay, so there are different ways of formula, both of them used. Okay, so this is an example of a table where we run the analysis, and this can be found in Hosmer-Lemaitre book. Sorry, in Clembaum. Okay, Clembaum book, page 477. So we have uh, column for variables, we have column for estimate, we have column for standard error, and a column for symbol. Because sometimes if you have many categories, it is easier to make mistake or to what we call accidentally pick the wrong value for the for the intercept and also for the covariate. In this example, we have three outcomes. Okay, three outcomes. So that's why we have intercept 1 and intercept 2. We have only one variable race and one variable estrogen. Okay, one variable, one regression value for race and one regression value for estrogen. This is one good thing if you run proportional odds model, because if you run adjacent category or continuation ratio model, you will have one beta value. If you have uh, three categories of outcome, then you have two beta value for gender and two beta value for age and two beta value for other covariates. Okay, and because of that, sometimes you need to do some constraining of the beta to get the average beta value. However, in proportional odds model, um, it is not a problem. You will have only one beta value for each of the covariate. Only thing is that you'll have um, j minus 1 intercept, okay, or d minus 1 intercept. If you have three categories of outcome, then you will have two intercept. If you have four categories of outcome, then you have three intercept. And if you look here for race, again, if you have race 1 versus 0, then this means for race 1, the the log or the odds or um, the log odds to be in the category greater or equal to category 2 is 0.427. If you have uh, 1 for value estrogen, then you have the log odds of minus 0.776 to be in the category greater than or equal to category 2, which is poorly differentiated. Okay. Okay, in categories less than 2 is in category greater equal versus less than 2. Okay, so we have 0 1 2, so 2 versus 1 0 and 1 versus 0. Okay, it's a little bit, it's complicated. Yes, it is complicated because of the ordinality. And I think it becomes clearer when we do the practicals later. So the odds that the tumor grade is in category greater than or equal to 1 versus category less than 1. Okay, this one is the odds that the tumor grade is in the category greater than or equal to 2 versus category less than 2. So this is from claim bound. So from here we can see that claim bound use the greater versus lower category, whereas um, Hosmer use equal or smaller versus larger response. Okay, so different approaches by these two groups of people. So because of that, be careful when you use the software. Understand which model are they using. Okay, so that your interpretation will make sense. If not, it will be 180-degree different. So let's see what can here see here. Right, I think we can skip this. All right. Even though it is much easier to use or to estimate uh, ordinal outcome using proportional odds model, and because of proportional odds model, you have only one beta value per race and one beta value for estrogen and for other covariate. However, it does not come uh, cheaply lah. Okay, it will come with an extra assumptions, the proportional odds assumptions. Um, the failure to reject the null hypothesis. However, be careful because even though the null hypothesis is that the uh, the proportional odds or the odds are similar between groups or in all groups, and the alternative hypothesis says that the odds are not proportional between uh, or among them. Okay, the proportional odds are not the odds are not proportional as the alternative hypothesis, and the null hypothesis says the odds are proportional. Okay, but you have to be careful. Even though you run the proportional odds assumptions, and the p-value is not significant, bigger than 0.05, and because of that you do not reject the null hypothesis, and you conclude that the odds are proportional, it might not be correct. it might be wrong because all these hypothesis testing are affected by the sample size. Okay, you might not have enough data to reject the null hypothesis. That's number one. Okay, in the case where the proportional odds assumptions are or is violated, it means that you got the p-value for the proportional odds model of less than 0.05. Let's say you set the level of significance at 0.05 and you get the p-value of 0.02. So which means that you reject the null hypothesis and you says that uh, the odds are not proportionate. Then what you need to do next, because you can no longer use ordinal logistic regression or proportional odds model or cumulative link logic model. So what you can do now is to go back and run the analysis using multinomial logistic regression. Okay. Okay. How do we do this in R? Okay. So first, of course, you have to read data and then do a little bit more exploratory data analysis and build your model using the packages uh, for data with ordinal outcome. Assess your model, make prediction, and interpret. In exam, this exploratory data analysis is not important, okay? Because we assume that you are good at it already. And always start your analysis with a new project. For the general packages, we can use Haven if you want to read data from SPSS, SAS, or Stata. Tidyverse to perform exploratory data analysis or to make plots, and summary tools as an additional package to run exploratory data analysis. Okay, so you just type library tidyverse, library, oh yes, one more, broom, um, to make a nice table outputs from your analysis. Okay. For this should be ordinal data, okay, not multinomial. Wrong here. Okay. We can use two packages. One, the ordinal package with the function CLM, and the other one is the mass package with the function polr. Okay. So let's activate library ordinal, and then um, we are going to use a sample dataset first for this brief brief practice lah before you go to the long practicals. So the dataset comes with the package, and the name of the dataset is wine. Okay, comes from a paper by Randall 1989, a factorial experiment on factors determining the bitterness of wine. Okay, there are two covariates, temperature and contact. Each temperature and contact has two levels. Okay, no and yes. Temperature, I think hot and cold, if I'm not mistaken. And rating, response. Okay, response of wine bitterness, 0 to 100 continuous scale, and from this they group into five levels. Okay, five levels. All right. So I think so this is the outcome, five levels, and these are the covariates, temperature and contact. I think for our example we are going to use only these three variables. Okay, so we run after we activated the ordinal package, then we use the function clm. The y or the outcome variable is rating, and two covariates, temp and contact, data wine. So you got the link logit, you got 72 observations. This is the log likelihood, and this is the log odds, right? The log odds, and this is the threshold coefficients. Stata used cut, and CLM used threshold. And if you run the analysis in Stata, you'll get similar results for here. Okay, for beta standard error you'll get similar results for z value and p value, but you get different things here because in Stata it use cut, while in R for CLM it use threshold coefficients. These values are not meaningful except when it comes for calculating probabilities. Okay, I think the minimum level that, or the not the minimum lah, I think the level to pass for the exam is to be able to estimate this and to be able to interpret correctly and adequately this log odds. Estimate the log odds and then convert to odds ratio. I think that you do that and you'll get pass lah. Okay, but to get better marks, then you have to know this to estimate the probabilities manually. You can do that automatically using the package, but I think it is quite interesting to understand how probabilities are calculated in ordinal logistic regression. So the log odds for temperature, which is warm temperature, has 2.50 log odds to be in the what category? Yeah, I forgot already this one. Greater or equal to lower. Okay. So the warm temperature has 2.5 times the log odds to be in the greater category of outcome. If there has been contact with the wine, then the log odds to be in the greater category will be 1.53. Okay. 1, 2, 2, 3, 3, 4, 4, 5. Okay. And this is if you use tidy, then you can convert this crowded output to a better output, to a nicer output. All right. Conf.int will provide the 95% confidence interval, and these are the main interests. Okay. If you use exponential true, then you'll get estimate here as the odds ratio. this is when we do prediction. Okay, so I predict. I need to first remove rating, because rating, because the rating in the dataset is not required for prediction. And then I predict using the O1 model, this one, okay, on the new data. And then I observe the first 15 observations, and this will tell me for the first one what would be the probability of outcome 1, what is the probability of outcome 2, 3 and 4 and 5. You remember we have 5 categories of outcome, right? So by knowing temperature and contact, we know that for the first observations there is 20.7% probability in category to be in outcome 1, 57% to be in category 2, 19.2% category 3, so on and so forth. Okay, so if you sum these probabilities, you get 1. Okay, you will get 1. This will produce the predicted probability. You can also produce the predicted class. Okay, so I use the same functions predict, the same model O1, but now I'm using type equal class, and it will tell you the predicted class for observation number 1 until number 20. Okay, so if you see here, this is group 2, category 2, category 2, category 3. Why? Because this is the highest predicted probability. 2, 2, 3 and 3. Okay, to check for proportional odds model, you can use nominal test functions, right? Nominal test O1, and it will test each of the covariates whether each one of them violate or does not violate the proportional odds assumptions. Or you can also use a nominal equal tilde contact to check for a specific covariates proportional odds assumption. You can also use polr function from mesh package. Same formula here, same arguments. It use Hessian method, and if we look at the value here, 2503158, let's see. Okay, it's the same, they are the same, right? 2503158. Okay, 2503158, the same results from polr if you compare with CLM. Okay, let's see the intercept. 1344. Okay, let's just copy and paste. Okay, 1344, 1.2508, 3.46, 5.0067. So they are the same. It's just that one comes from ordinal package and the other one comes from Mass package. Okay. And in if you use predict for for an object that comes from polr, you must type you must specify the argument for uh, parameter type, which is props. Okay, so you get the same probability for the outcome. Yes. So I think that would be the overview uh, of the concept for analyzing ordinal outcome data, and a very very short introduction to running uh, ordinal logistic regression in R. In the practicals, in your note, the practical note, the, it is I it's very long, because one of the example that given is the one that comes from Hosmer Lemeshow book. So and um, we do a significant, or spend significant time to do data wrangling to what we call manage the outcome of the categories and whatnot, just to replicate the results in the Hosmer Lemeshow book. But really, to run ordinal logistic regression is very simple. You just use CLM, identify the outcome variable, identify the covariates. That's it. Okay, it's very simple. Okay.